Alright guys, we are going to do your critical care drips. We are still using the 10th edition of your Dosage Calc book, okay? So I'll give you the page numbers for you to follow along. You need to go to page 479, it's chapter 17, and it's the beginning of your critical care drips. So you all remember that when we infuse fluids into a client, we can do it two ways, by gravity, where we count the drops per minute, or by the IV pump. What you need to understand about critical care drips, because these medications can dramatically affect our client, especially based upon their weight, we will always use a pump, because a pump is much more effective than us using our eyes to manually count a drop as it goes in, and it's much safer. So for all your critical care drips, we're always going to place them on a pump, okay? These are the X's you will have to solve for critical care drips. You, of course, will have to know the mLs per hour because that's your infusion rate. We need to know how many milliliters or volume we are giving to a client per hour. And then because our critical care drugs are majority of the time based upon weight, we really need to understand, hey, how much milligrams or how many micrograms or how many micrograms per kilogram per minute is going into our client. So we're going to learn how to solve all these things. For you all to perform critical care drips, you all need to understand your King Henry doesn't usually drink chocolate milk. Don't forget the ... mu, because we need to know how to convert, for instance, grams to micrograms, or maybe convert milligrams to kilograms. Or you could have memorized your chart, whichever way you want to do it. And just remember that, for instance, 1,000 micrograms always equals 1 milligram, 1,000 milligrams always equals 1 gram, 1,000 grams always equals 1 kilogram. And because these are weight-based medications, you should always know that 1 kilogram equals 2.2 pounds. In case your client's weight is given in pounds, we still have to know how to convert to kilograms in order to solve our problems. So, let's go ahead and jump into it. I want you to go to page 480, and we're going to start with the example at the top of the page. And you all know I only teach the method of dimensional analysis for how we solve our math problems. So in dimensional analysis, we're reading our example. We always look for our X. We have to figure out what we're solving for. So it says lidocaine 1 gram has been added to 500 mLs of D5W. The order states to infuse the lidocaine at 2 milligrams per minute. The nurse needs to calculate the rate in mLs per hour. And it even gives you a rounding rule. It says round to the nearest tenth. Remember, the NCLEX has now transitioned. It will say round to the first decimal or the second decimal. First decimal will mean round to the nearest tenth. Second decimal will be round to the nearest hundredth. So just remember on your exams, for NCLEX purposes, we will say round to the first decimal or round to the second decimal. So what is your X? Your X, it says calculate the rate in ml per hour. So our X is ml per hour. My method of solving everything in dimensional analysis is to put everything in the equation. However, some students prefer to go ahead and convert things prior to put it in the equation. I'm going to show you both methods for the first two examples, so you figure out which method you like the best. I need to remind you that you are to never convert weight outside of the equation. For instance, if a client weighs 60 pounds and you divide that by 2.2 to get your kilograms, and it ends up being 30.95432, whatever it is, we cannot cut off that weight in decimals. You have to use that entire weight because we are giving the medication to the entire weight of the client. So be mindful. I never want you all to convert your weight outside your problem because you might get a decimal and we'll have rounding errors at the end because we're trying to chop off the client's weight. Alright, so we are looking for mLs per hour. We know in dimensional analysis you start with milliliters. We have to find what in our problem has milliliters in it. And it says lidocaine 1 gram has been added to 500 mLs of D5W. So we know we have to start with our milliliters right here at the top. So remember, it says 500 mLs to, don't forget it's always linked to something, to 1 gram of lidocaine, correct? Well, we're not looking for ml per grams, we're looking for ml per hour, so we got to get rid of our grams. So now we're going to our equation and we're looking for something with grams in it. However, we see there's nothing else with grams in it. There is something with milligrams in it. Doesn't it say it's to be infused at 2 milligrams per minute? However, we can't throw milligrams up here because they won't cross off. But isn't it true, if we have memorized or understand that 1 gram is equal to 1,000 milligrams, that still is the number 1. So we can put 1 gram to 1,000 milligrams, right? This is equal to this, so it truly is the number 1, not affecting our equation at all, and our grams crosses out, okay? Now we have milligrams, and we need to get rid of our milligrams because we're looking for milliliter per hour, not milliliter per milligram. So we do have information with milligrams in it. It says 2 milligrams per minute. Your milligrams can cross off because it's on the top and the bottom. And we're looking for ml per hour. It's still ml per minute. We need to get rid of this minutes. Well, what relationship do we remember about minutes to hours? We understand there's 60 minutes in 1 hour. Make sure to put your 60 minutes on top so your minutes can cross off on both top and bottom. And it's per 1 hour. And now when we go back through, everything's crossed off except for the x we need. And you need to ensure that ml is on top in the numerator and that the hour is in bottom in the denominator. And always make sure you multiply the entire top across, you multiply the entire bottom across, then you divide at the end, okay? So when you multiply that across, you should get 60,000 divided by 1,000. And when we do 60,000 divided by 1,000, we should get 60. Don't forget to always label your answer, mLs per hour that we are giving, okay? So this is the example. This is my preferred method. We are converting our numbers in the problem, okay? However, I'm going to show you another way to do the same type of problem. If you are really a King Henry type of person, then I will show you how to convert outside of the problem before you start your dimensional analysis. So again, we're on the same problem, the example at the top of page 480. We are still looking for ml per hour. Well, we're looking in our problem and we see, hey, we have milligrams and we have grams, okay? So you always start your x. And it says 500 again, 500 mLs to 1 gram, correct? Well, we need somehow to get milligrams because our information says 2 milligrams per minute. So instead of putting this 1 gram at the bottom of the 500 mLs, you can go ahead and convert that. You should understand if we take 1 gram, remember our gram is right here at our units, we put our decimal right here, and we need to get to milligrams. We start with the next one over, and we go to our milligrams. So we need to move our decimal 1, 2, 3 over. So 1, 2, 3, that's our new decimal, okay? We put zeros for those 3 places we moved over, so we understand that 1 gram is equal to 1,000 milligrams. So if you want to go ahead and convert your information before you plug it in, that's completely fine. It will give you the same answer. So instead of 500 mLs to 1 gram, you can say that you have 500 mLs because we know 1 gram equals 1,000 milligrams. And then you still have something you can work with in your problem because you know the lidocaine is infusing at 2 milligrams per minute. Milligrams crosses out. We need to get rid of our minutes and we need to get hours. So we know there's 60 minutes to 1 hour. Minutes crosses out. We are left with our x. You multiply across and you divide by the bottom. It's still 60,000 divided by 1,000 equals 60 mLs per hour. Same exact answer. It's just you go ahead and take the units that are different and convert them outside and plug it in your equation instead of doing what I do right here. Same thing, okay? Okay. I want you to flip over to page 481. and we're going to do the example at the top of the page. It says the order is to infuse nitro at 5 micrograms per minute. 50 milligrams of nitro has been added to 500 mLs. When you read your problem, you can see, hey, I have micrograms and I have milligrams. So you should automatically understand I'll have to be doing some conversion of some type. And the nurse needs to calculate the rate in mLs per hour. So you know your X is mLs per hour. Again, I convert in my problem as opposed to doing it beforehand, so that's what I'm going to start with. So what information do you have about mLs that you have to start with in the numerator? You have 500 mLs to, it says 50 milligrams of nitro. Well, we need to get rid of our milligrams. We see we don't have milligrams in our problem, but we have micrograms. So we just need to think about what is our relationship for milligrams to micrograms, and if you remember, 1 milligram always equals 1,000 micrograms. So I can put my 1 milligram on top to be able to cross it out, but I got to make sure I put my 1,000 micrograms at the bottom. And then we do have information in our problem with micrograms. It says there's 5 micrograms per minute. Our micrograms crosses out. We have ml per minute. We need ml per hour. So we understand there is 60 minutes. We get the minutes on top, so they cross out to 1 hour. Now we're left with our X. We multiply all across the top, and you get 150,000 divided by 50,000. And you should be getting 3 mLs per hour when you do that math. Again, if you're a King Henry doesn't usually drink chocolate milk, don't forget your moo. We will convert beforehand. And this is the last time I'm going to do this example. Here on out, I'm just going to convert within the problem. So we already read our problem, and we know we have micrograms and we have milligrams. So we need to make sure that we take we need to make sure that they both are either micrograms and they both are always milligrams. So let's look. We know we have to start with our mLs on top. And it says we have 500 mLs, again, to 50 milligrams. Well, the next information is micrograms, so I'm going to go ahead and convert this outside of the problem. And we have 50 milligrams, correct? Well, I need to understand how many micrograms is it. So we're going to use our King Henrys to move it. We have 50 milligrams, our decimal's right here, and this is our milligrams. So it tells us, we always start to the next one over, we need to move our decimal 1, 2, 3 to the right. So I'm going to take my decimal 1, 2, 3. Here's my new decimal. Fill in my zeros. And I understand that for 50 milligrams, I have 50,000 micrograms. So instead of putting the 50 milligrams at the bottom, you can go ahead, since you've already converted it, and put 50,000 micrograms at the bottom so you don't have to convert within the problem like I do. And just proceed on like that. And then we need to find micrograms to get rid of. It says we have 5 micrograms per minute. Micrograms crosses out. We have to get rid of our minutes. We know we have 60 minutes per 1 hour. Minutes is on top and bottom, so it crosses out, and we're left with our X. We do the math all the way across. Still the same thing. 3 mLs per hour. So again, whatever you prefer. If you're a really big King Henry fan, then I suggest you convert your units to the same units outside of the problem. Don't ever convert a client's weight though. Please don't, because you'll get a crazy decimal sometimes, and it's very hard to put a big long decimal inside of a problem. So if you're a King Henry's fan, convert outside and then plug it in where it needs to go. Okay? This is the last example I'm going to do with that style of converting outside. I'm just going to continue with the style I recommend of always converting within your problem. So, I want you to flip over to the example at the top of the page 483. Now we're starting to get into our different X's. We know ml per hour is the infusion rate that we calculate our pumps for. Well, now we're going to start getting into the milligram per minute, microgram per minute, and then kilogram per microgram per minute. So let's start with the top of page 483. You read your problem. A patient is receiving lidocaine at 60 ml per hour. The concentration of lidocaine is 1 gram and 500 mL of D5W. And it states the nurse needs to calculate the milligram per minute. So that's our X. Our X is milligram per minute, correct? Well, we always have to start with our numerator right here. We need to find something with milligrams in the problem. As you can see, there's nothing with milligrams in the problem. It says 1 gram per 500 mL. But don't we know that 1 gram is equal to 1,000 milligrams? So truly, we need to make sure we put milligrams on top. If we say 1,000 milligrams is equal to 1 gram, this number is just 1 because they're equivalent to one another. It doesn't change our problem. And we get our numerator on top, which is what we need. Okay? Now we got to get rid of this gram, and it does tell us that our client is getting 1 gram of lidocaine in 500 mL. So we need grams on top. Make sure to put 1 gram over 500 mL. Grams crosses out. Now we need to get rid of mLs. Well, it says the patient is receiving lidocaine at 60 mLs. mLs on top, so we get rid of it per 1 hour, right? Now we're left with milligram per hour. We need to get minutes on the bottom, and we know our relationship with hour to minutes. 1 hour, so hour goes on top, is equivalent to 60 minutes. So our hours marks out. We are left with milligram per minute. We do our math. That should be 100,000. Sorry, should be 60,000 divided by 30,000. And when you do that math, you should be getting 2 milligrams per minute. So it is saying that the client is receiving 2 milligrams per minute of the medication. Okay? Let's drop down to the example at the bottom of the page. Now it's asking for, let's read our problem. A patient is receiving nitro at 3 mLs per hour. The concentration of nitro is 50 milligrams and 500 mLs, and the nurse needs to calculate the microgram per minute in which the patient is receiving. So our X, we always look at the end of the problem. Our X is microgram per minute. So we're looking at our problem. We have no information about micrograms, but it does tell us that 50 milligrams is in 500 mLs of sodium chloride. However, you cannot put milligrams on top. We have to start with our numerator. But isn't it true that we know 1 milligram is equal to 1,000 micrograms? That just is the number 1. So we're going to put our 1,000 micrograms on top is equivalent to 1 milligram. Okay? This truly is the number 1. It doesn't change the problem at all. And now we have information in our problem about milligrams. It says 50 milligrams is in 500 mLs. So our milligrams can cross off. We have microgram per milliliter. We need microgram per minute. So we got to get rid of our mLs next. And it tells us that it is infusing at 3 mLs per hour. mLs crosses out because it's on top and bottom. And now we have to get to minutes. We understand the relationship for hour to minutes. 1 hour is equivalent to 60 minutes. Hour crosses off. We are now left with our X. So when you do the math across, it is 150,000 divided by 30,000. And when we divide that all out, we should get 5 micrograms per minute. That is our answer. Okay? And again, if you like the King Henry's way, you could have, because we needed to get the micrograms, we could have went ahead and converted our 50 micrograms, right? I'm sorry, we could have converted, it says we have 50 milligrams in 500 ml, right? But we need to start with micrograms, so you should have thought 50 milligrams equals how many micrograms, right? So 50, our decimal's right here, our milligrams is right here. We need to move the decimal to the right, 1, 2, 3. 1, 2, 3. Fill our zeros in. That's our new decimal. So 50 milligrams equals 50,000 micrograms, correct? And you could have started your problem with 50,000 micrograms is in 500 mLs of fluid, okay? Still the same thing, and then you start from this step on and do the same thing all the way through if you want to convert beforehand. Okay, we still have to look at a problem with finding the microgram per kilogram per minute. So I want you to go to page 484 and look at the bottom, the example at the bottom of the page. And what it says is the patient is receiving dopamine at 12 mLs per hour. The concentration of dopamine is 200 milligrams and 250 milliliters of sodium chloride. And the nurse needs to calculate the microgram per kilogram per minute. The client weighs 70 kilograms. So when we're working with three factors, or three entities, remember, this is your X. We're looking for microgram per kilogram per minute. Your microgram, or your first entity, is the only thing that goes on top, and everything else goes on bottom, okay? So what you need to understand is you will always need to have the micrograms at the top of the equation, and you need to ensure that kilograms and minutes stays at the bottom of the equation, okay? So let's look in our problem, and we have to find something with micrograms. There's nothing with micrograms in it, but we do see there's 200 milligrams and 250 mLs of sodium chloride. Well, we know if you're the King Henry, go ahead and convert your 200 milligrams to however many micrograms, but I like doing it within the problem. We understand, we always need to start with micrograms, that 1,000 micrograms equals 1 milligram. Because we got to make sure our numerator is the first thing we start with. Now we need to get rid of milligrams, and we have information with milligrams. It says 200 milligrams is in 250 mLs of fluid. Milligrams crosses out on top and bottom. Next thing we need to get rid of is the mLs. We see that we have 12 mLs per hour, correct? mLs crosses out, okay? Well, we're not looking for microgram per kilogram per hour, we're looking for microgram per kilogram per minute. So we need to make sure we get minutes on the bottom, and don't we know that 1 hour is equivalent to 60 minutes, correct? So we got a lot of good stuff. We got microgram on top, and we got minutes on bottom. However, we are missing our kilograms. And the information we have related to kilograms is our client's weight. Our client weighs 70 kilograms. So that is its own entity. You don't change your client's weight. It's not correlated with anything. And we just know we got to get kilograms on the bottom. So you can put 1 over 70 kilograms to get your X that you need at the bottom of your equation. Okay? And then when we do the math all the way across, it is 2,400,000 divided by 1,050,000. And when you divide that all out, it comes out with a crazy number like 2.2857 blah blah blah. I will give you a rounding rule, and let's round to the first decimal. So since it was 2.28, you are going to say that you are given 2.3 microgram per kilogram per minute. That is your answer. Just make sure, people want to treat that 70 kilograms as 70 kilograms, and it is 70 kilograms. However, you always need to remember, if we have the kilogram at the top of the equation, if you would have flipped this and said 70 kilograms per 1, your kilograms is not where you need it to be in your equation. So just put 1 over the 70 to get kilograms at the bottom. Okay? We're going to do 2 more problems to make sure that we have seen every type of potential problem that can be thrown at us. But I want you all to flip to the worksheet, okay? I want you all to read the worksheet's page 491, and I want you to read number 1. The physician orders dobutamine 12 microgram per kilogram per minute for Miss White, who weighs 75 kilograms. The concentration of dobutamine is 1 gram in 250 mLs. How many mLs per hour should the IV pump be programmed for? Well, again, we always find our X, and it's asking us for mLs per hour, correct? Well, we always look and see what information do we have with mLs in it, okay? And it tells you the concentration is dobutamine 1 gram in 250 mLs. Make sure you always put your numerator on top. So you need to make sure you put the 250 mLs on top to the 1 gram, all right? Now we got to get rid of the gram on bottom because we don't want grams, we want hours. And we're reading our problem and we have no information with any further grams in it, but we do see the micrograms, okay? So we either need to understand that 1 gram is equal to 1,000,000 micrograms, or you can go ahead and convert your grams to micrograms before you put it. So you could have put 250 mLs over 1,000,000 micrograms right here, and then you should have plopped to your information you have with micrograms. But I convert within, and now my grams crosses out, and I understand I need something with micrograms in it, which I have. Pay very close attention to this. The information you have about micrograms is it is 12 microgram per kilogram per minute. That is one entire entity. You cannot cut off anything related to it, and it has 3 components. So you will make sure that you put the 12 micrograms on top, but you have to put the rest of it at the bottom. Kilogram per minute, okay? So micrograms crosses out. We like our milliliters on top, but now we have these other 2 things we got to get rid of. Well, we know we need to get to hours, and we also know we need to get rid of this kilogram. Well, let's start with the kilogram. What information in your problem do you have related to kilograms? You have the patient's weight, and the patient weighs 75 kilograms. So to get rid of the kilograms, we have to put the kilograms on top. And isn't it true that the patient's weight is 75 kilograms over 1? That's still the same number, and kilograms marks out. Now we're good. We got rid of kilograms, and the last thing we got to get rid of is minutes. And we understand our relationship with minutes to hours, which is what we need to get to, is 60 minutes per 1 hour. Minutes crosses out. We circle and make sure that we have our X, and our X is where we want it. mLs is on top, hours is on the bottom. Well, when we do all that math, it ends up being 13,500,000 divided by 1 million. And then when we divide that all out, we get 13.5, and make sure you label it correctly, mLs per hour. Just make sure, because you're using something with an entity with 3 components in it, make sure the 1 goes on top and the 2 go on bottom, okay? And then the last example I'm going to show you, we've worked with everything. If we're using a patient's weight in terms of kilograms, you can see when a patient's weight is in pounds. You'll need to know how to solve that in your equation. And remember, I don't want you converting weight outside because you can get a very long decimal. But we do know 1 kilogram always equals 2.2 pounds, and we're going to use that inside of our equation. So I want you to look on page 491, and I want you to look at example 3. And I know it tells you that the patient weighs 80 kilograms. I want you to mark that out, and your client's weight is now 176 pounds. And you have to figure out your X with a client that weighs 176 pounds. So let's read it. The physician orders dopamine at 5 microgram per kilogram per minute. The concentration is dopamine 2 grams and 250 mLs of sodium chloride. And now the patient weighs, he doesn't weigh 80 kilograms, he weighs 176 pounds, because we need to figure out how to manipulate pounds in our equations. And it says how many mLs per hour. So your X is ml per hour. Right? It's going to be a really long one. Actually, let me write it a little closer over here because it's going to be a pretty long equation. So we always know we start with our numerator. The information we have with mLs in it is 250 mLs. It has 2 grams in it. Okay? So we need to make sure we put the mLs on top. 250 mLs has 2 grams in it. Well, we're looking to get rid of the grams. We have no information with grams in it, but we do have information with micrograms. So we either need to go ahead and convert outside the problem, and you should have put your micrograms. 2 grams equals 2 million micrograms right here. Or I convert in the problem, and I'm going to say 1 gram is always equal to 1 million micrograms. Okay? Grams crosses out. Now we can work with micrograms because we have information with micrograms in it. It says the dopamine is ordered at 5 microgram per kilogram per minute. Again, 3 components. You need to make sure that one goes in the numerator and the other 2 go in the denominator. So we have 5 microgram per kilogram per minute, correct? Well, microgram crosses out. We're looking for ml per hour. We have our ml up here, but we need to get rid of the kilograms and we need to get rid of the minutes. Well, let's start with our kilograms. We don't have any information with kilograms because I told you the patient weighs 176 pounds, not 80 kilograms. But we do understand that always 1 kilogram, we need to put it on top so it crosses out, is equal to 2.2 pounds. Always. It's universal. So we can get rid of our kilograms, and don't we have information with pounds in it? We know our patient weighs 176 pounds, and we just keep that as one entity. We can put 176 pounds over 1, and then our pounds marks out. Okay, so we use this to get our kilograms and into our pounds, and to have everything cross out. Now the last thing we got to get rid of is our minutes. And we understand that 60 minutes is always equal to 1 hour. Minutes crosses out. We are left with our mLs per hour. And when we multiply everything across the top, you should have gotten 13,200,000 divided by 2,200,000. And when we do that math, it works out to 6 mLs per hour. And that is how we manipulate pounds if our client's weight is given in pounds. All right. Thank you very much.